How can the musings of ancient philosophers connect with the cutting-edge theories of modern quantum mechanics? Let's untangle this intriguing connection, starting from the philosophy of Aristotle and Aquinas, and journeying all the way to contemporary theories in quantum mechanics. From the dawn of philosophical thought, Aristotle and Aquinas pondered the nature of change, the actuation of potentiality, and the concept of an unmoved mover or prime mover. In his article, Coyne Hasn't Got a Prayer, Michael Egnor states the prime mover argument as such. 1. Change exists in nature too. Change is the actuation of potentiality, and an essential chain of actuations cannot go to infinite regress. A fully actual prime mover is necessary. 3. That prime mover is what all men call God. In short, Aristotle and Aquinas reasoned that the unmoved mover, God, is the source of all change. And as Egnor succinctly stated in his article, Aquinas First Way and a Stack of Books, the prime mover is the source of all change. In him we move and breathe and have our life. He is closer to us than we are to ourselves. Fast forward to the 20th and 21st centuries, when quantum mechanics emerged as a scientific revolution. It was in this context that Werner Heisenberg, one of the pioneers of quantum mechanics, realized the striking parallels between Aristotelian philosophy and quantum theory. He observed that the probability wave, a fundamental concept in quantum mechanics, was a quantitative version of Aristotle's concept of potentia. Specifically, he stated, the probability wave of Bohr, Kramers, Slater was a quantitative version of the old concept of potentia in Aristotelian philosophy. It introduced something standing in the middle between the idea of an event and the actual event, a strange kind of physical reality just in the middle between possibility and reality. Michael Egnor further noted, to an Aristotelian like Heisenberg, quantum mechanics isn't strange at all. This philosophical perspective offers a unique lens through which to view the famous double-slit experiment, a cornerstone of quantum mechanics. In explaining the double-slit experiment, Nobel laureate Anton Zeilinger made these following rather stunning statements which mesh perfectly with this ancient prime mover argument. He stated, "The path taken by the photon is not an element of reality. We are not allowed to talk about the photon passing through this or this slit. Neither are we allowed to say the photon passes through both slits. All this kind of language is not applicable." And he also stated, "We know what the particle is doing at the source when it is created. We know what it is doing at the detector when it is registered, but we do not know what it is doing in between." And although, according to Anton Zeilinger himself, we cannot know exactly what the photon is doing in the double-slit experiment between emission and absorption, we do know that while a photon is doing whatever it is doing, in between, in the double-slit, that the photon is mathematically defined as being in an infinite dimensional state. An infinite dimensional state which takes an infinite amount of information to describe properly. As Wikipedia states, the set of all possible wave functions in some representation for a system constitute an, in general, infinite dimensional Hilbert space. And as stated in the article, why does describing a quantum state take an infinite amount of information? Describing the wave function precisely takes an infinite amount of classical information, since it takes values in a continuous space. To state the obvious, describing the quantum wave prior to collapse as existing in an infinite dimensional state corresponds to the theistic attribute of omnipresence, whereas describing the quantum wave prior to collapse as requiring infinite information to describe it properly corresponds to the theistic attribute of omniscience. Obviously, this aligns with the prime mover argument, suggesting a connection between the omnipresent and omniscient attributes of the prime mover and the properties of a quantum system. In conclusion, the philosophical concepts of Aristotle and Aquinas, particularly their prime mover argument, resonate deeply with the principles of modern quantum mechanics. All in all, this deep resonance is rather stunning confirmation that this ancient prime mover argument is true. From Heisenberg's interpretation of quantum states as manifestations of Aristotelian potentia to the infinite dimensional state of a photon in the double-slit experiment mirroring the omnipresent and omniscient attributes of the prime mover, the connections are profound and fascinating. Moreover, the The fact that these ancient philosophers could anticipate the basics of quantum wave collapse centuries before quantum mechanics came along is nothing short of astonishing. Many scientists today simply dismiss philosophy as being completely irrelevant to science. Yet, this remarkable parallel between ancient philosophy and modern science suggests that ancient philosophy has far more to offer science than today's scientists seem willing to believe. As George Ellis stated in the article titled, "Physicist George Ellis Knocks Physicists for Knocking Philosophy," physicists should pay attention to Aristotle's four forms of causation: